Alright, so if you've seen Maury, where they fight over the baby daddy, or if you've watched CSI or any of those crime scenes, you've seen gel electrophoresis or seen at least the byproducts of it being used, whether you know it or not. Alright, gel electrophoresis is a really cool tool that we can use for multiple different things to look at our genes. All right, so when they're trying to find the baby daddy and the parent, they're going to pull this out. They're going to take blood DNA samples and use gel electrophoresis. All right, so this is pretty interesting too. So what you're going to have to do is you're going to have to interpret gel electrophoresis, and this is what it looks like here. This little square here with all the bands, and you're going to have to understand why we use it. So first, let's talk about the various uses. All right, so the baby daddy. So here we go. Here's this woman, and she's pregnant, and there's two dudes there. Which dad is hers? Well, what you do is you take a sample of the baby's DNA, which we can get. She's full enough long term there. You can take a sample of all of their DNA. And remember, the DNA should match half, so half of these bands. So if we go back up one slide here, half of these bands should show up because these bands are DNA, should match the mom, and half of them should match one of these guys. All right, so we would have to figure out, and you're actually going to do that in the activity, of which one of these guys matches the mom. All right. Matches the baby to figure out who the baby daddy is. So you can figure out who committed the crime. So you find blood evidence here at the crime scene, and maybe that's left by the perpetrator. So you're going to then put that on a gel, and if his DNA, the suspect who you suspect did it, if his DNA matches that DNA at the crime scene, he did it. You can figure out if what a new species is. So if you find a new species, you can figure out what its DNA is and compare it to other species to figure out what it's most similarly related to. That's kind of like this scenario where you're finding who the baby daddy is. And then you have the genetic diseases are present. So if you want to find out if somebody has sickle cell or a specific genetic disease, and you can even do a whole family here and make a pedigree out of it. So you know what the genotypes are, and we know how the DNA, that's what these bands are, the DNA shows up. And then we can just compare. So big A, if whoever's big A would have two bands here, 1, 2. So this guy has 1, 2. So this person right here would be big A, or unfilled in. The rest of these people would be carriers, big A, little a. They have 3 bands. So this brings us back to a pedigree. So everybody who has 3 bands is halfway filled in. And then the persons who have sickle cell have 1 band. And they are fully colored in because they have the trait. All right, so what you guys are right now, what you're going to do is you're going to go to this animation and just go through and answer those questions, and then I'll show you how to analyze these. So it's pretty easy. All right, so this is the example of the baby daddy. So who is the father of this child? So here's the mother. And here's all her DNA bands. So again, these bands are just DNA. All right, and the reason why they separate that is because this DNA down here is very, very small, and the smaller DNAs go farther through that gel, whereas the longer DNA, like this one here, stays up towards the top because it's really big. It can't fit through the little tiny holes that are in the gel as easily, so it stays up there. So what we're going to do is, we're going to compare the DNA. So the DNA, these red bands are all the DNA the child got from the mother. You see how they match up? So that means these are the same genes. This is the same gene, same DNA there. So the child inherited it from the mother, but remember, it inherits half of it from the father. So now we're going to look at the two dads. So this child inherited this DNA. Could have been inherited from father 1 or from father 2. So we don't know yet which father it is. This child only matches, this band only matches father 2. And this band only matches father 2. And this band only matches father 2. So this baby was from father 2 and not father 1. All right, because he had the same DNA, he inherited that DNA, same DNA from his father. Over here, forensics is when you try to solve a crime. So we have the blood stain from the crime scene. And obviously, if they did it, their DNA would match up perfectly with the blood stain. So you go through these bands. Right now, they all have the top band. The second band, only Bob, John, and Lisa does. So Sue is out. This next band, Bob doesn't have it, the blood stain. And John does, and Lisa doesn't have it. So we don't even have to go any farther. John's DNA matches perfectly with the blood stain, so that means the blood stain was his blood stain. This is the DNA that came from him because it's exactly identical. Remember, everybody has specific, unique DNA. So that's how we can solve the crime. All right, so then what you're going to do is go through the activity, and there's a baby daddy scenario, there's a crime scenario, and there is a disease scenario, and you have to even make a little pedigree off of that disease to kind of go back and review that. All right, so that's what you're doing in this activity.